Hey everyone. So, let's talk about a problem that I know you've felt if you've used AI for more than 5 minutes. Amnesia. You spend all this time teaching an AI exactly what you want, and then a week later, it's like you've never met. Well, today, we're going to dive into a really fascinating new architecture that's built to solve exactly that and give AI a real long-term memory.
I mean, seriously, right? How many times has this happened to you? You had this amazing, detailed conversation with an AI, you get it perfectly dialed in, and then the next time you log on, poof, it's a complete stranger. That feeling of digital amnesia is just so jarring, especially now that we're trying to use these tools for big, complex, long-term projects.
And this memory gap is becoming a huge deal because we're not just building simple chatbots anymore. A chatbot, yeah, it can get by with a short-term memory for just one conversation. But an AI agent, the kind of tool that's getting woven into our actual work, it has to be stateful. It needs to remember context over days, weeks, even months. For these new agents, memory isn't just a nice-to-have feature, it's the absolute foundation.
Okay, so let's get into the weeds a little bit. To really get why this new solution is so cool, we first have to understand the problem. Why do AIs forget in the first place, and what are the real limits of the memory systems we're all using right now?
So, for a while now, the go-to solution for AI memory has been this technique called retrieval augmented generation. You've probably heard of it as RAG. The easiest way to think about it is like an open book test. Every single time the AI needs to remember something, it frantically searches through this huge library of documents to find the answer. But as our AI agents get more complex, this constant searching, well, it can be really slow and pretty inefficient. It's quickly becoming a major bottleneck.
So, if constantly searching an external library isn't always the answer, then what is? Well, that brings us to a totally different way of thinking about the problem. A new kind of memory. Let's talk about something called observational memory.
Okay, so what is it exactly? Well, instead of constantly searching outside for information, observational memory basically works by keeping a running diary inside its own memory. You have these little background agents that are always working, compressing your conversation history into a super clean, dated log. And here's the key. That log always stays in context. The AI never has to go looking for it. And because of that, it completely eliminates the need for that slow, dynamic retrieval. It's a total game changer for both speed and cost.
A running diary sounds cool, but how does that actually work under the hood? Let's break down the mechanics, which are actually pretty simple but really powerful. It all comes down to two key players, the observer and the reflector.
The whole system is built on this really clever idea. The AI's working memory, what we call its context window, is split right down the middle. One side is for your raw, real-time conversation, what's happening right now. And the other side is for those compressed observations, that clean, efficient log that acts as the AI's long-term memory.
So here's the life cycle of how it all works. First, your conversation grows in that raw messages block. Once it hits a certain size, let's say 30,000 tokens, which are just pieces of words, this little agent called the observer wakes up. Its whole job is to read that conversation and compress it down into these neat, dated notes. Then it files them away in the long-term memory block. And once that's done, the bulky raw messages are just dropped to save space. Finally, to keep everything tidy, a second agent, the reflector, periodically sweeps through that whole long-term log and condenses it even more. Pretty smart, right?
Now, this is a really, really important point. This compression we're talking about, it's not just a simple summary. A typical summary might give you the general idea, but it loses all the critical details. What observational memory creates is way more like a pilot's logbook. It's an event-based record of exactly what happened, when it happened, and what decisions were made. And for an AI agent trying to stay consistent, that structured log is way more useful.
Okay, the theory sounds pretty elegant, I get it. But does it actually perform better in the real world? Let's look at the data, because this approach has a pretty big impact on performance and, maybe just as importantly, on cost.
And yeah, the numbers are pretty compelling. When they tested this on a benchmark that's specifically designed for long-term memory tasks, this observational approach scored higher than a standard RAG system. And check this out. That's using the exact same underlying model, GPT-4o. It just goes to show you that for certain tasks, how you manage the memory can be just as important as the AI's brain itself.
But honestly, this next point is the real showstopper, especially for anybody who's paying the bills for these models. Because that memory log is so stable and consistent, it allows for something called prompt caching. Basically, if you ask the same thing twice, the system doesn't have to redo all the work from scratch. This simple trick can lead to a massive, and I mean potential tenfold cost reduction. Most RAG systems can't do this because their prompt changes a little bit with every single search, which constantly breaks the cache.
I think Sam Bhagwat, the CEO of Mastra, the company behind this work, really sums it up perfectly. He says, it has this great characteristic of being both simpler and it is more powerful, like it scores better on the benchmarks. I mean, come on, simpler architecture that performs better? That's pretty much the holy grail in engineering.
Okay, so this new approach is clearly powerful. But does that mean RAG is dead? No, not at all. This is all about choosing the right tool for the right job. So let's break down exactly when you might want to use observational memory and when RAG is still going to be your best bet.
This table really makes the trade-offs crystal clear. Look at that top row. If you're building a long-running agent that needs to remember its own history like a personal coding assistant, observational memory is going to be your best friend. But if you need an AI that can answer any question from a massive external knowledge base like a research tool, RAG is still perfect for that kind of open-ended discovery. It really just boils down to one fundamental choice. Are you prioritizing what the agent has already seen and done, or its ability to search everything it could possibly ever see?
And hey, this isn't just a theory. Companies are already putting this to work. I mean, imagine an agent inside your company's CMS that actually remembers your editing style from 3 weeks ago. Or think about an AI helping your engineers that can recall exactly which system alerts it's already looked at. For these kinds of professional tools, memory isn't just a feature, it is a core product requirement.
All right, let's zoom out for a second and look at the big picture. What we're really seeing here isn't just some clever new tech. It actually points to a fundamental shift in how we think about building AI for the real world. This is all about why memory is so quickly becoming the absolute foundation for production-grade AI.
So if you're out there building AI systems, these are the exact questions you should be bringing to your next team meeting. How much context does your agent really need to do its job? Is a perfectly compressed diary of its own experiences more valuable than the ability to search a giant external database? The answers to these questions are going to define your entire memory strategy.
And let's just end right where we started, with the user experience. Sam's quote says it all, doesn't it? It's just jarring when you've told an AI something important, and it just forgets. Ultimately, solving this memory problem is about building AI that feels less like a forgetful tool and a lot more like a reliable partner.
And that leaves us with one final, pretty provocative question to think about for the future. As these AI agents become our collaborators, our assistants, and even our systems of record, is it possible that the design of their memory will eventually become even more important than the specific model that's powering their brain? Something to chew on. Thanks for joining me.